Lesson 8.3, or lesson 4 for us in our exponential chapter, is going to be basically comparing linear and exponential functions again, but this time kind of using it and deciphering those out of story problems. So just to remind ourselves what a linear increase would look like, that would be a line with a steady, constant slope with the equation y equals mx plus b, where m is our slope and b is our start amount. And then exponential growth is the new stuff that we've been learning. And remember, that doesn't cross the x-axis, but does cross the y, and then continues to grow faster, bigger. And then this equation is y equals b times g to the x, where b is your start amount, and then g is your growth rate. And remember, this is either going to be a percent, or it's going to be words like double or triple, or maybe even quadruple. Okay, so the difference between these two is if we are adding or subtracting, okay, which is increase, and exponential growth, meaning we are multiplying by the same amount each time. So multiplying by double, triple, quadruple, etc. So let's go ahead and look at some examples. Example A says, suppose you have $10. Your rich uncle agrees to give you two options on some money. Option 1 is to increase what you had each day by $50, or option 2 is to increase it by what you had by 50%. So if I just kind of look at option 1, increase what I had by $50. That is a set rate, which means this is going to be linear. So that means I'm going to plug it into my y equals mx plus b. So my slope then is what I'm changing each time. So that'd be $50, so 50x, plus the $10 that I'm originally starting with. So that equation would be y equals 50x plus 10. My second equation is going up by 50%. Okay, so now that I see my percent, I know that's going to be my exponential. So that means I'm going to need y equals my b times g to the x. So again, I'm starting with $10. Growing by 50% would mean that I need to take that, divide it by 100 to get 0.5, and then add 1. So that would give me my 1.5 to the x. And you should be getting more familiar with these because this is our fourth and exponential, so these should look mostly familiar to you. So I can go ahead and just fill out my table using my equations. So on day 0 here, I have $10, then I've got 60, 110, and so on. Okay, over here on my second equation, I start off with $10, I multiply it by 1.5, then I've got $15, multiply that by 1.5, and I've got $22.50. So I'm going to have you pause right now, fill in the rest of your table, and then play when you have finished that. So by now, you should have your entire table complete, and go ahead and check to make sure that it matches mine. On day 10 for my linear equation, I have $510. On day 10 of my second option, I have $576.65. So the type of growth, obviously the first one is linear, and then my second one we said is exponential. Okay, again, remembering that exponential is getting faster, bigger, okay, and then linear just means it's going by the same rate the entire time. So now we can answer the 3 questions below. Question 1 says, if I waited only 1 week, which would be 7 days, which deal is better? So at 7 days, right here on my 7th row, that would obviously be option 1. Question 2, if you waited 10 days, so waiting all the way down here to my last row, which would be better, that is going to be option 2. I've got another $66 in option 2. And question 3 says, at what point would you change your mind? So at what point does day 2 start to be bigger than day 1? And that looks to be right on day 10. And then everything after. So every day after that, because it's exponential, it's going to stay bigger, okay, and the linear is never going to catch it. So day 10 and every day after would be a fantastic answer. All right, let's go ahead and try our second example here. 2 villages will each have 50 inhabitants. Suppose village A grows by 20 people each year and village B grows by 20% each year. Okay, so if you had a hard time writing the equations first, okay, in our last example, we could just go ahead and fill in the table. So Village A starts with 20 people, and then it grows by, it starts with 50 people, and then grows by 20. So the next year I'll have 70, 90, 110, 130, etc. Well, now I should see that that's going up by the same amount, which means my slope is my 20 people, and then my starting value was 50. So then I should be able to write that my equation is y equals 20x plus 50. Okay, just kind of very similar to what we done a couple days ago. Whatever your rate goes right here for your slope, and then your starting value is always what number you have here on day 0. Okay, so then if we want to do the same thing, work backwards on our Village B, I still start with the same 50 people, but this time I'm growing by 20%. So I need to take 20% of 50 and then add that to 50, and that would give me 60 people. Take 20% by multiplying by 0.2, add it to 60. That would give me 72. So we're probably better to write our equation pretty quickly here. So I'm going to start with my 50 people, and then 20% would be 1.2 to the x. Okay, again, taking 20%, dividing it by 100, and adding it to 2 because I am growing. Okay, so go ahead and pause me again, fill in that table, and see if you can also fill in the type of growth as well down here. Okay, so by now you should have your table filled in, and you should go ahead and check that your table matches my table. Notice on the right-hand side you may have gotten decimal answers, but we are talking about number of people, so I would have rounded. Okay, so you can go ahead and see that our change is that our Village A is bigger until about, let's see, where is it? Where does it change here? Right in the 8th year. The 214 is going to be bigger than the 210, so there's kind of that changing year, and then from everything after that, your blue, or your Village B, will be bigger, okay, because it's exponential versus linear. So if you wanted to go ahead and give me a graph, linear, okay, would include this, and then exponential would include this. Now look, and I notice I only graphed it in the first quadrant because we're talking about a village here, okay? So I should have a linear and a exponential growth, both only in the first quadrant. So then I can ask the questions, which type of growth is more likely? Okay, exponential is more likely. Population growth is the most common use of exponential functions, okay, because people do not always, populations don't flux normally. And then when will populations be equal? So we said about 8 days is where that changes. Okay, so let's go ahead and just try our one last example, example C. Label each type of situation as constant increase or exponential growth, and then sketch. So an increase of a debt by 5%. Percent is a dead giveaway for exponential, okay, and then exponential growth. And then again, a sketch would be an exponential growth here. Okay, an increase of $5, okay, per month. Remember that word per always meant linear, so this is going to be a constant increase, and then sketch a line for me. Number 3, 2x plus 5 is in the form mx plus b, which means that's a constant increase, again, and that's a straight line. My last one, 2 times 5 to the x, because x is up here in the exponent, that is going to be exponential, and it's going to be growth because this number is bigger than 1. So again, I can go ahead and sketch an exponential growth. So today is your 4th day working with exponential, so hopefully it was a good day. Go ahead and do your homework, which is going to be your last worksheet in your homework packet, and I will see you tomorrow.